So the presentation I want to start with is Opamp Types, types of operational amplifiers. And you can see it here. Because we are going to use operational amplifiers as controllers in our negative feedback amplifiers. So we must know about the types, about the models, and this is what this lecture is about. So there were already operational amplifiers in the time of vacuum tubes. And maybe it is interesting to visit. They were used as, that's where the name comes from, they were used as amplifiers in analog computers. So, oops, sorry, let's go to the Radio Museum. So here, if you click the link, then you can go to the Analog Computer Museum and find a lot of examples from history. Like here they have a collection of analog computers, and they were used to solve things like differential equations by using integrators and differentiators and adders and all this kind of stuff. And here you see a few examples of analog computers. You can dive in it yourself, of course, if you just go to this website. And early types were equipped with vacuum tubes, so the operational amplifier is not specifically a thing that is only available in, was only firstly available in integrated circuits. So they're used for analog computing, and I told you the first one was a vacuum tube operational amplifier. There's a lot of stuff about this amplifier also on the web. So here you have the first operational amplifier. It has two triodes tubes, and here you see some applications like integrators and differentiators and adders. And here you see the internal circuit. It's just nice to go to the web and learn a little bit about the history of this operational amplifiers. But of course, we are, so then you, after the vacuum tube types, you had some kind of PCB assemblies that had operational amplifiers, and here you see a specification. You can also find it on the internet. And in 1964, there was the first integrated circuit operational amplifier from Fairchild. And you can find this information, of course, also on the internet. So nowadays, there are many operational amplifiers. And although the word operational says something about, well, it's a generic element, you can use it for controller in many systems, you have many different types. So it's maybe good to view what is available nowadays. And here you have the analog devices site. You should go to the analog devices site, but I'm thinking it's not. Well, we do it like this. And then you go to products and operational amplifiers here. And then you see all kind of operational amplifiers. They are classified in different types. And here is a special product selection table that you can select on their properties. Another manufacturer of operational amplifiers, well, there are many, of course, but another important one is Texas Instruments. So you do ti.com and you have the same type of products here. Amplifiers, it's all, the websites, of course, are different, but here, operational amplifiers. And also they have classified them in different classes, and you can search the whole thing from their selection table. So what is the problem for our design of the controller or selection of the controller? There are so many. So because there are so many, you can just say, well, let's pick one and try. If the circuit that I want to make works, just put this controller in our amplifier. But what we are going to do is first model these operational amplifiers, so we know a little bit more how to model their behavior in different aspects. We will model them separately. And then from our design, we will try to find requirements for the operational amplifiers as to narrow the search, that we don't have all these thousands of devices to deal with. So the first thing is the modeling of the operational amplifiers that we want to do. Well, the types we have, the types is a voltage feedback operational amplifier, and the type has to do with the structure, the internal structure of the operational amplifiers, and we don't want to go into that in this course. So I just give you the names: voltage feedback, high common mode and differential mode input impedance, low equivalent input offset voltage, and it can have a rail-to-rail output. I will explain later what is a rail-to-rail output. A current feedback operational amplifier has a strongly asymmetrical input stage, and it has different properties and is used for usually high-speed applications if you want a high rate of change from the voltage at the output. Then a new, let's say, quite modern type is a fully differential operational amplifiers. They are used to have differential input and differential output, and they are applied in RF front ends for high-speed analog to digital converters. Then another class is the zero drift operational amplifiers. As we will find out later, the properties of the operational amplifier change with temperature, and for very low frequency applications in, let's say, you could almost say DC applications, you want to have a very high temperature stability. And for this, they applied specific techniques, and they developed zero drift operational amplifiers. That's just a few classes and overview that we have here.